Today, ladies and gentlemen, we are going to talk about how to predict the products of a single replacement reaction. You've had some experience doing the online simulation where you look at how the metals behaved in the ionic substances. And what we noticed is not every metal will react with every ionic compound that's out there. What you created was an order or a ranking of the metals based on their reactivity. So the more reactive a metal is, the more likely it is to bond ionically. The less reactive it is, the more likely it will be to stay as a neutral elemental form. So what we see for a tool to use to predict the products is our activity series. So the list you see posted in the lower left there is an ordering of the metals from most reactive to least reactive. You will be provided this resource on any test or quiz moving forward. Your job is simply to know how to use it. So the trick for single replacement is we always want to identify the element that's by itself, the singleton. Once we know whether it's a metal or a non-metal, we're going to know which chart to use. So over here on the left, the one that you see is the list for the metals. The non-metal list would be separate, and I can only compare like elements, because otherwise, if I traded a metal with a non-metal, I wouldn't have an ionic compound in my product. So the way that this would work is that, let's say I was looking at trying to decide if potassium would switch with zinc chloride. So I find the potassium in the list. And then I find the zinc in the list. And what we see is in this case, potassium is higher on the list. That means it's more reactive, and it's the singleton. The switch is going to occur. So they're going to trade places, just to put our correct formula there, which would mean I would make KCl, and then zinc would be all by itself. To fully balance then, I'd have 2 of those and 2 of those. Now let's say instead I had copper and I wanted to see if it would react with calcium chloride. In this case, when I look at the copper, oh, look at that. I picked one that's not on the list. We'll make it cobalt. When I compare the cobalt to the calcium, since the cobalt is less reactive and the more reactive element is already part of the compound, that means nothing is going to switch. So let's take a look at a few more examples. So here we have calcium plus lithium chloride. So first I'm going to find my calcium on the list, which I got right here. Okay, and I have my lithium. So that means lithium is higher, and it's already in the bond. So since the higher or more reactive element is already in the bond, this would have no reaction. You can kind of think of this like a popularity contest. The one that's more reactive is more popular and wants to hang out with other elements more. The one that's less reactive, you could kind of think of as less popular and might be more inclined to spend their time alone. So I know it's a silly example, but it helps connect to what's going on with the elements. Remember what this is really showing is a tendency to give up those electrons. Now in our second example, we have sodium and we have aluminum. So this time the singleton is higher. So the switch will happen. The sodium is going to switch places with the aluminum. So sodium will bond with a -2 carbonate as Na2CO3. That then leaves the aluminum to be the element by itself. So to balance, it looks like we need 3 of these to get my carbonate. That means I'm going to need 6 of my sodiums, and I have 2 Als from over here. Now the last one, I have I2, and I have lithium sulfide. So since this is a non-metal, you will have to check your non-metal series. So I had to go and look it up online because I did not have that cropped piece of the diagram, but you can see the non-metal series over here now on the right. In this case, we have iodine by itself. We have sulfur in the compound. Iodine is higher and wants to make the switch with the sulfur. So here, Li is a +1, iodine is a -1. They'd be in a 1-to-1 ratio. And then sulfur would be left as the element. To finish balancing then, I'd put a 2 here to account for it. Notice that when writing formulas, I have to write the formulas based on their correct charges. So for example, when I made the Na2CO3, the reason that I did it that way is because sodium is a +1 and the CO3 is a 2-. So to have the correct proportion, I had to have 2 NAs to cancel out the -2 CO3. Once you have the correct formulas, then you can balance the equation. Don't be tempted to carry subscripts across from other places. So I'm just going to clean things up a little bit so that you guys can see the examples with a little bit less writing in them. And you will then have access to an activity series from me or the substitute teacher, and you will be expected to use it while you do your work and your practice today. So please make sure that as you work on the worksheet, an answer key is posted, and make sure that you understand that you are using the activity series to answer these questions. You can't do this without using that activity series.